Number 18. Morgan throws a ball up into the air. The height of the ball above the ground in feet is modeled by the function h of t equals negative 16t squared plus 24t, where t represents the time in seconds since the ball was thrown. What is the appropriate domain for this situation? Well, our first thing is vocabulary. Our domain is t, not h of t. So when we're talking about t, we're talking about time. And so the question is really, how long is the ball in the air? So when I look at my answers, I do want to work smarter, not harder. When I look at the four answers to this question, two of them talk about the h of t. The h of t is the height of the ball, not the time that's passed since the ball's in the air. So answers 3 and 4 to this question don't make any sense. Those are distractors, so I can eliminate them before I do anything else. Now, what I want to do is graph this function on my graphing calculator and see how long that ball is actually in the air. Now, before I open my calculator, notice that I rewrote my equation in terms of f of x. I know the first graph in my calculator is graph f1. So f1 of x equals negative 16x squared plus 24x. Because if I start putting t's in my graphing calculator, nothing good's going to happen, and I'm not going to get any closer to the answer. So now, home screen, new doc, say no to drugs, and we want to add a graph page. So negative 16x squared plus 24x. Now, if you notice our graph, this is a parabola. It goes up, up, up. It comes back down. But this starts at the origin and it never makes it to 2. So my height could go up pretty high, but my x-axis is limited to somewhere between 0 and that looks like about 1.5. So when we look at our answers, our value of t, the domain for this situation, that ball is in the air for approximately 1.5 seconds. And that's the only part of the graph that really matters, because after that, the ball might touch the ground, but it's not going to be under the ground. So all those negative values in the function won't ever exist. And that's our answer to question number 18.